In this video, we're going to look at a bunch of practice problems that involve simplifying trigonometry expressions. So these are the 12 problems that we're going to solve. If you want to give them a try yourself, you can pause the video and do that now. Otherwise, we're going to jump into question 1. So for question 1, we have tan squared t plus 1 over 1 plus cotan t. So we should immediately recognize that both of the top and bottom expressions are derived from one of the trig identities. The top part is equal to secant squared t, and the bottom is equal to cosecant squared t. Secant is 1 over cosine, so this is going to be 1 over cosine squared t, and then the bottom, cosecant squared, is going to be 1 over sine squared t. Then we can rewrite this as sine squared t over cosine squared t. And tangent is sine over cosine, so because these are squared, it's going to be tan squared t. And that is our final answer. Alright, for question 2, we have 1 over secant t minus tan t minus 1 over secant t plus tan t. So first step here is we want to get a common denominator on both sides, which means we're going to have to multiply this side by secant t minus tan t over secant t minus tan t. And we have to multiply this side by secant t plus tan t over secant t plus tan t. Okay, now we can write the entire top as a single expression. So it's going to be secant t plus tan t minus secant t, and then I got to distribute the negative, so it's going to be plus tan t. It's all going to be over secant t plus tan t times secant t minus tan t. First thing we should notice is that these secants cancel out. And then the tricky part here is the bottom is actually the difference of squares. So in our previous video, we talked about how we can factor polynomials that look like this, and they turn into something that looks like this, x plus y times x minus y. So I guess normally you're looking out for this direction, you're looking for an x squared minus y squared, but you should also be able to recognize when the reverse is the case. So here we have a plus and a minus where both terms are the same. So we can rewrite this whole thing as 2 tan t over secant squared t plus tan squared t. Or not plus, this is a minus. Now, this bottom part is a trig identity. It is equal to 1. And so we can rewrite this equal to 2 tan t. And that's our final answer. For question 3, we have secant t times tan t times cosine of t. This one is actually really quick. Secant t is 1 over cosine t. So if we write this all out again, these two cosines are going to cancel, and this equals tan t. For question 4, we have sine squared t times cotan t times cosecant t. So what we want to do is rewrite each of these in terms of sine and cosine. This cotan is going to be cosine t over sine t, and cosecant is just 1 over sine t. So now we can cancel out all of these, because on the bottom, if we multiply these together, this would give us sine squared t. So these two cancel, and we are left with cosine t. For question 5, we have 1 minus cosine squared t over sine squared t. We should recognize that the top part is equal to sine squared t from one of our trig identities. So when we write it out like this, we'll see that the final answer is just 1. For question 6, we have tan squared t over 1 minus secant squared t. So if we write out one of our trig functions, which was 1 plus tan squared t equals secant squared t, and then we subtract a 1 across, we'll get secant squared t minus 1. So it looks similar to this, but it's not quite right. So what we need to do is multiply each side by a negative 1. So we're going to have negative tan squared t equals 1 minus secant squared t. Then we can plug in negative tan squared t. So this is going to be tan squared t over negative tan squared t. And our final answer is going to be negative 1. For question 7, we have tan squared t times cosecant squared t minus 1. From one of our trig identities, we can figure out that what this part equals. So we know that 1 plus cotan squared t equals cosecant squared t. And if we subtract the 1 across, t minus 1, this is what we have here. So we can rewrite this as tan squared t times cotan squared t. Cotangent is the reciprocal of tangent, so this is actually tan squared t over tan squared t, so this equals 1. For question 8, we have 1 minus cosine squared t over 1 plus cosine t. This one is a fun but tricky one because the top is actually the difference of squares. So because this is 1, this is actually like 1 squared. So we can rewrite the top as 1 plus cosine t times 1 minus cosine t. This is all going to be over 1 plus cosine of t. Then these are going to cancel, and we're going to be left with a final answer of 1 minus cosine of t. For number 9, we have cosine squared t over 1 minus cosine squared t. So from our trig identities, we can figure out that the bottom is equal to sine squared t, because cosine squared t plus sine squared t equals 1. If we subtract this across, we'll have sine squared t equals 1 minus cosine squared t. So this is this. And then here, cosine squared over sine squared is equal to cotangent squared t. And this is our final answer. For question 10, we have secant squared t minus 1 over tangent t. So the top we know is equal to tan squared t from our trig identities, and that's going to be over tan t. So this is going to cancel with one of the tangents, and we're going to be left with tan t as our answer. For question 11, we have tan t plus 1 over secant t. So this we can rewrite as tangent of t plus 1 over cosine t. Then we can rewrite it as tangent t plus 1 times cosine of t. Tangent is sine over cosine, so this is going to be sine t over cosine t plus 1 times cosine t. And then we're going to basically distribute that cosine. So we're going to have cosine t sine t over cosine t plus cosine t. Cosines here are going to cancel, and we're going to be left with sine t plus cosine t. The last problem we're going to look at in this video is question 12, which is 1 plus cotan t over cosecant t. So we're going to follow a similar path that we did to the last question, where we're going to rewrite the bottom as 1 over sine of t. Then we're going to bring it to the top like this. We're going to distribute the sign, so we're going to have sine t plus, and I'm actually going to break apart cotangent into cosine t sine of t over sine of t. So this part here is the cotangent. Then we're going to cancel out these signs, and our final answer is sine t plus cosine t.